Welcome, grade 9. We're going to look at some exercises from the Mind Action series based on similarity. So if you look at this one, this question says that we must show, so it means you must prove, that the following triangles are similar. So what does similar mean? Similar means that the sides will be in equal ratio. For example, the one side will be 2 in the one triangle, and the other side, for example, will be 4. So it means if you simplify this, 2 and 4, the ratio will be 1 to 2. In the same way, for example, this one can be 3, and this one will be 6. So if you simplify the ratio, it will again be 1 to 2. So that's what it means. And the requirement for two triangles to be similar is that you must have 3 angles that are equal. 3 angles are equal. So that's when you have to prove that 2 triangles are similar. You can either just prove that the 3 angles are equal, or like in this case, they gave us the sides. So now we're going to prove that the sides are in proportion. So they can ask it in any of these 2 ways. So with this one, we're just going to show that the sides are in proportion. So they specify here that we must work with triangle PDE, and we must work with triangle PQR. So the ratios that we are going to analyze would be PD. You see, I'm not proving anything at the moment. I'm not proving that it's similar. I'm going to prove that the ratios, that the sides are in equal ratios. So let's see, or in equal proportion. Same thing. PD on top of PQ. So let's see, what is PD? PD is 3. And PQ is going to be that whole length there, which will be 3 plus 9 centimeters. That will give me 3 over 12. And if you simplify that, it's 1 over 4. Let's now look at the next one, DE on top of QR. DE on top of QR. So DE will be 2,6, and QR is 10,4. Pop that into your calculator and you will get 1 over 4. Then the last one will be PE over PR. And PE, let's see on the drawing, PE is 2 centimeters and PR will be 2 plus 6. That gives me 2 over 8, and simplify that into 1 over 4. So what do we see? All these ratios are equal. So therefore, the sides are in proportion, and therefore triangle PDE will be similar. Similar is always for vertical lines, similar to triangle PQR. Just quickly, how can we remember the difference between similarity and congruency? With similarity, do you see these 3 lines going down, the eyes? So that's how we remember similarity. While with congruency, it's when the 2 triangles are exactly equal to each other. So you think of the equal sign, that you just add the third line. Let's look at the next one. We must analyze this question and show that the two triangles are similar. So again, we just have to show that the sides will be equal in proportion. Sides equal in proportion. But what's the problem with this one? Well, with this one, if you compare this one with the previous one, they actually gave us the two triangles. But here, they didn't give us the triangles. So what we will have to do is we're just going to create the triangles. Right, but we can't do anything before we have the sides. So let's analyze what did they say here. The first information here is saying that EC will be equal to 2 times AE. So do we have EC? No, we don't have AC, but we know that EC will be 2 times the length of AE. So EC will be equal to 2 times AE, and AE is 4 centimeters. So EC will be 8 centimeters. Let's see what else. It says here that BE will be half the length of DE. So let's see where's BE. Okay, here's BE, this one, is going to be half the length of DE. So if this one is 3 centimeters, this one will have to be 6 centimeters. Then BE will be half the length of DE. Another way of writing this, you could have got rid of the half by multiplying by 2. So 2 times BE will be equal to DE. And BE we have as 3 centimeters. So therefore DE will be 6 centimeters. For the last one, it says here that the ratio of AB over DC is 1/2. The ratio. They're not saying the centimeters, they say the ratio. So AB will be 1 and DC will be 2. So these are ratios. We can't say with certainty that it will be centimeters because they didn't specify centimeters there. So let's see. Now we can prove it. Show that the two triangles are similar. So now that we have all the ratios and the sides, what will the two triangles be? Well, if you analyze this, if that's a 1 and this one is a 2, then it means this side will go together with this one. This side here, let's just work with red or just with any other color. This one is 3 and this one is 6, so you multiply by 2. So those two sides will be together. Why am I doing this? It's just so that we can get the naming order right now. And if this one is 4, this one is 8. So these two sides will go together. So let's see, how would we name this? Doesn't matter where you start. It's like you can start with from any 3, sides. It doesn't matter where you start. I'm just going to start off with triangle ABE. So let's see. AB is that white line. AB, ABE, and then E has the 90 degrees, right? So now we must find the other triangle. So if it's ABE, right? AB is the white line. So then it means we must work with DE. C. Now, is it going to be DC or is it going to be CD? Let's go back to this one. AB. The B goes towards the red line. You see, AB. So it goes towards the red line. So I'm not going to say DC because DC will go towards the purple line. So I'm going to say CD, going towards the red line. You understand what I'm saying? For the naming of the two triangles, because we don't have any angles here except these two 90-degree angles. I can't say these lines are parallel. I can't. Right, not now, but you can say it afterwards. Because then it means the angles will be the same. So in triangle ABE, AB going towards the red line, and C, so I'm working with this white line and this white line. CD going towards the red line, and the final one goes towards E, which has the 90-degree. See, so I'm just indicating the equal angles there. Just for myself, you don't have to show that. I can't work with angles because I don't have angles. So what I'm going to do, I'm going to work with my sides. So AB over CD is 1 over 2. I'm going to say given, because they gave it to us. BE over DE. BE, let's see. BE is 3 centimeters and DE is 6 centimeters. Why was that? It was also given. BE, they said it's half of DE. That was given. Or you can say proven because, we proved it. And that is equal to 1 over 2. Then the last one will be AE. I'm running out of space. So underneath that one, you must write AE over CE. AE is 4 and CE is 8. I'm just going to say here, it's equal to 1 over 2. And why is this 4 over 8? It's proven because we already proved it there. Therefore, the triangles, they all have ratios of 1 over 2. Therefore, triangle ABE will be similar to triangle CDE. And I'm not going to say angle, 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 because we didn't work with 3 angles. I'm going to say the sides are in equal proportions. You can say the sides are equal in equal ratios. This one. Show that these triangles are similar. So I decided to use these 3 examples because it's like slightly different. So the previous one, we worked with the 3 sides. And now we're going to work with the actual angles. So if I see 2 triangles like this, I always suggest that you split them up. So it's way easier. So I'm going to split up A, B, D. There's A, and A is just a dot, and there's B. Then the other triangle will be D, B, C. Right. So what do we see here? That's B1. As long as you have two angles that are equal, then the third angle will also be equal. For example, if you sit with a triangle that's, let's say, 10 degrees there and 10 degrees there. Let's say I have one there that's 80 and 80. Then the third angles will be equal. Why? Because of interior angles of a triangle. So if this one is 80 and that one is 10, it adds up to 90. And interior angles must add up to 180, so 90 plus 90. So that one then must be 90. Same with this one. If that one is 10 and that one is 80, it will add up to 90. Therefore, this one will be 90. So let's prove it. We just need to work with two angles. I'm going to say in triangle, and we have to work with this order that they gave us. It's always easy. I'm always relieved if they actually give us the triangles. In triangle ABD and triangle BCD. So now you can start with any of these two angles. I'm just going to start with angle A and angle B2. Angle A is equal to angle B2. Why are they equal? Because it's given. There's dots in there. Angle D2 there is equal to angle D1. Okay, why is D1 going to be 90 degrees as well? Because it's adjacent angles on a straight line. A, B, D, that one will be 90 degrees, and B, C, D, that one will also be 90 degrees. So they're just trying to confuse us a little bit with this 90 degree here, right? Because we're not going to use this one. So you will say D2 is equal to D1, is equal to 90 degrees. I would just say, yeah, adjacent angles on a straight line. And now that we've got two angles, the third angles will be equal. So let me just show you where are the third angles. So in the first one, it will be A, B, D. So this would be the third angle. And in this triangle, it will be B, which we have, it's equal to A, B, C, D. So the unknown will be this one. So that would be the third angle. So therefore, in the small triangle, it will be B1. So therefore, B1 will be equal to angle C. My reason will be because of interior angles of a triangle. So proving this, you need to find two angles, and then the third one, the unknown one, those will be equal. Therefore, triangle ABD will be similar to triangle BCD. Now that we worked with angles, we just say angle, angle, angle. Right, so that was the three questions for this presentation. A thing that's very important to take from this is that, let's say Apiwe decided to start off with D2 and then say angle A. It's fine. And very often it doesn't matter, you know, in which order you start. And, you know, maybe Mikhail decided to start with angle 1, with that one, like I did. It doesn't matter. As long as you set it out in some sort of order that makes sense. Right.